So just we've seen conditional jump instructions. Next one, that is the unconditional jump instructions. As the name indicates, unconditional means there is no conditions at all. But even though we need to make the jump here, at the time we are going for this concept. There are two are there. One is the LJMP. JMP stand for jump. This is the L stand for long jump. Similarly, this is the S, it means short jump. So check the first one. LJMP, that's a long jump. It is a 3 byte instructions, mainly consisting of the 3 byte. So in the second one is, this is already I said, this is the unconditional long jump. There is no conditions at all. Out of 3 byte, first byte is going to tell about the operating code. OP, this is the technical word, is very important. OPCOD means first OP stand for operating code. Operating code is nothing but some of the if I return something like the move here. So here move is nothing but it is going to tell about moving the data. If you go for something the CPL is nothing but complement. That means for the particular operations we are having the particular instructions. Is it clear? So that means by using the opcode, it is going to tell like that what you are going to perform particularly. So whether it may be the move or the complement, or there are a number of instructions are there. So what you want to perform, that is going to tell by the operating code itself. Second and third byte, out of 3 byte, remaining second and third byte, it is going to represent the 16-bit address of the target. That means where you want to make the jump, that particular jump location address is going to give by the second and third byte. So that means second and third byte is nothing but total, this is 8-bit, this is also 8-bit. That means total 16-bit address it will provide. 16-bit address means the range, obviously it will be the 4 zeros to the 4F. So this is the maximum range we can provide. So when we are using that some of the microcontroller, when they will provide the 64 KB ROM, maximum we can interface 64 KB RAM. If you are using 64 KB RAM, at the time it will provide this much huge memory addresses. Similarly, S jump is nothing but this is also the short jump, but it is only the 2-byte instructions, where the long jump is 3 byte. 2 byte is nothing but same. First byte is going to tell about the opcode. Opcode means this is operating code. What you want to perform, it is going to speak about this one. Second byte, it is going to relate to the address where you want to make the jump to the particular target address. So obviously this is second byte. This is only 1 byte is left. So that means maximum range it will be the 00 to the double F only. So more than double F I can't give, because of this is only the 2-byte instructions. If it is 3 byte is nothing but I can give this much range. So by seeing the range only you can understand 4 zeros to the 4F is nothing but this range is longer. That's why the name itself, this is long jump. This range is only 00 to double F. This is the short range. That means this is the short jump. So again in this they are going to mention like that forward and backward jump. Forward and backward jump is nothing but if my execution line is here, my program ready to execute the some instructions here. Is it clear? So that means I return the something like instructions here, GC something I return here. So for a program counter having this value, is it clear? I need to make jump to the further address. Further is nothing but if I give the next next here, this next I return here. Clear? So program instruction line is here. If this condition is true, it will make jump to the here. That means what I can say here, if you want to make the jump to the from this line to the further lines, that means I can say this is a forward jump. Some conditions based on this instruction here, I need to make the jump to the backward. That means instead of going for further next line here, it will give the something like the jump label is here next. That means if you make jump from current program status word to the further, it is the forward jump. So if it is backward means from the present execution line to the backward jump. This is a backside. This is backward jump. That is nothing but if it is a forward jump, that address it will be the range from this up to the here. This range will be the plus 128 7 bytes. If you want to make the jump from the present line to the backward jump, that is a backward jump, this range it will be the minus 128 bytes. So just only conclusion is, in the forward jump range will be the plus 127 byte. In the backward jump the range will be the minus 128 bytes. So that means overall the conclusion here, in your exam they can ask explain the conditional and non-conditional jump instruction, means you need to explain this all. This is theoretical also, it is very important question, and this programming part you should understand this instruction set. Without knowing, or if you don't know at all these instructions, your programming becomes, you can't understand the programs. Even it may be the practicals or it may be the theory also. In all the modules little bit programming part is there, so everywhere you are going to use this instructions only. That's why I'm telling, if you understand the second module completely, so in the lab point of view you can understand programs very easily, and theory also you can write the programs very easily once you understood the instruction set only. Without instruction set you can't understand the programming part. That's why I'm telling, please watch the videos and make the repetition as much as possible.